Thank you for this great organization. Thank you for let me explain what we do, who we are, what we do. I'm going to explain a little bit what is Gestioniza Group, what are our capabilities, our experience, and so on. That is in our opinion, is very valuable for the current market and the current situation of the telecom infrastructure deployment here in Greece. Then I'm going to explain a little bit in a high level, the micro and nano trenching and horizontal directional drilling that are two techniques that we used to use in this kind of deployments of fiber optic networks. And then at the end, the advantages of these techniques. So this is Gestioniza Group. Gestioniza Infrastructure is an EPC contractor. EPC contractor, what we do is to manage all kind of telecom projects end to end, mostly in fiber optic networks deployments. Also, we have an ISP, internet service provider, called Fibritel. We have also a factory of fiber optic and pipes plant that we have located in Spain, and also a passive equipment for FTTH deployments that also we have in several countries. We have investment in open access networks, internet open access networks, and also a charity foundation in order to give back to the society what we get from them. No? We are operating, our origin is Spain, but now we are starting operations early this year here in Greece. We have a company that gives services in the telecom field in Colombia, and we are starting operations in United States. Also, everything related to telecom and optic fiber. As Gestioniza, as I mentioned before, we manage all kind of projects end to end. We are very specialized on backhaul and FTTH deployments. This is the core of the businesses, but also we have experience in mobile networks. We also, as I mentioned before, we supply equipment, fiber optic and pipe. We have some research and development innovations, like one of them is what we are using for the deployment of backhauls. What we do is to manufacture the cable, and when we manufacture the pipe, we allocate the cable inside. So once we lay this pipe in the backhaul deployment, the cable is inside and we don't need to blow up later. So we save a lot of time. We also have a division for software development and also for consultancy in network configuration, network designing. This is our experience. We have deployed more than 8,100 kilometers of backhaul. Backhaul means, for non so familiar with the terminology, backhaul is a connection of fiber between 2 points, long distance points, normally between villages, cities. I'm going to show you later in the coming slides some photos of these kind of deployments. One example of this backhaul deployment is one that we are doing now in Spain. Is 120 kilometers backhaul for Meta, the famous company. We are connecting Madrid with Talavera, one of the main data centers that they have between Madrid and Portugal. This connection, this fiber optic backhaul, we are deploying. We are the ones that we have designed, and we are making the deployment at this moment. Also in FTTH, as you see here, we have deployed more than 0.8 million home pass in Spain, mostly in rural areas. We have also deployed the rural areas using European European funds, subsidies that incentivize the company like us and our customers to arrive to rural areas. No? So important for the deployment of this area from technological point of view. Radio links, we have a lot of experience, more than 600 radio links installed for, in some cases, it's not so easy to deploy a backbone, and we had to connect point to point also with radio links. No? And also for 4G, 5G, mostly we made in Spain and also in Colombia. When we had to connect to points, no, in FTTH or in backhauls, one of the solutions is to deploy underground. No, all of us, we know the traditional trench, no, that you go with an excavator and you make you make a trench with traditional methods. No. But there are another two classifications like microtrenching and nanotrenching. The nanotrench or microtrenching is what you used to see here in the streets of Attica region. No, all the ISPs they are laying cables and that pipes through these nanotrenchings. Trenches up to 30 centimeters, let's say, and up to 80 centimeters depth, no? And then we call nanotrenching to those trenches that with less than 8 centimeters, we trench or we dig up to 40 centimeters. These two kind of trenches, we used to use special machines as those ones that you saw in the door of this place. The big ones we use for microtrenching, and the small one, there's this traditional, let's say, mini excavator with an attachment and application specific for trenching. No, let's see some photos of those trenches. Okay, this is a nanotrenching. This is a remote control nanotrenching machine. We can dig from 1 centimeter to 5 centimeters wide trenches, and this is very common for residential areas. That is not needed to install the microtubes, or in some cases we use for microtubes, but normally is for a pipe with just one cable inside. No, as you know, there are different architectures of fiber optic networks deployment. What is used here is the German one that is normally used microtubes with the fiber optic or blowed fiber optic cables, but then there is let's say the architecture that we lay direct cables and we splice the cable and we don't blow these kind of fibers. No, that is what we used to use in Spain. So this is a project here in Attica region. The nanotrenching machine, the first step. No, second step. We sweep up the surface, then we lay the cable, and then we cover with we restore the asphalt again. So these 4 operations can be done in the same day. This is one of the main advantages of this technology. This is very well known here, but the difference is that the trench we used to do is 3 centimeters instead of 12 centimeters. No, this is one of the advantages of this technology. So for microtrenching, we use similar heavy machine, similar machine but heavier. We see here one trench machine is similar as what you saw in the door of in the entrance. This is an example of digging a trench in a road, no, in the asphalt. Same, but in soil. This is the project that I mentioned before. This is the long distance backhaul for Meta. This is the first step, that we open the trench, then we lay the cable, as you saw here. In this case, this pipe has the cable installed inside. So we lay up to 2.5 kilometers between two handholds, so we don't have to blow the fiber just later. So we avoid one of the steps, no? You saw in the right photo, you can see in this case, we have two pipes installed inside, and then we pour concrete inside in order to cover. This is one of the specifications of Meta. We cover the cables with concrete, and then we lay a warning tape just in case in the future someone dig over here. Has to be aware that there is a fiber optic network over there. Okay. This is another technique. This is horizontal directional drilling. This is used for passing a special, let's say, a special events below, like a river, like a bridge, like a railway. Is very common to use in the backhaul deployments. This is an example of one city, and this is an example of one river. No, it used to be done in 3 steps. The first step is to make a pilot hole. Then what we do is to pass a bigger tool in order to open a bigger hole, and then we use that one for handling the pipe that will be installed forever. And inside that pipe will be installed the pipes with the fiber optic inside. Okay, those are the 3 steps. This is the machine. This is the horizontal drilling machine that let's say is put in one of the sides, and is going to make this hole for passing to the other side. No. The advantages of these techniques, as you can imagine, with the microtrenching, nanotrenching, we reduce very much the surface disruption, less cutting of roads or streets and so on, a faster deployment. We can save up to 50% of the time. As I mentioned before, in one day we can open the trench, lay the cable, and close and restore the pavement again in the same day. So also less time of disturbance to the citizens and the businesses. We can save, as was mentioned, 50%. Less environment impact. No, right now we are measuring what is the carbon footprint, and with these techniques we save a lot of carbon footprint. No, less waste material, since the trench is smaller. We are going to have less waste material, more than 60%. No, less cost for sure. What we have calculated is that the cost of this kind of trenches is less than 40% of the traditional trenching. Less restatement cost, less damages to other utilities, because the trench is less heavy machinery, and very direct, and it goes directly where we want to go. No, less permitting. And less permitting. And just for, I see that I have to finish. For directional drilling, similar as I mentioned for the trenching. Thank you so much. Yeah.